again, it's Cliff here from Down Under. Well, I want to wrap up this video series on R8 TTS versus BT30 spindle tapers. It's probably been dragging on for long enough now. In this video I'm going to summarize some of the points I've been talking about in the last 3 videos, and also bringing forward some of the comments that you've been putting forward to me, which have been really helpful. I'll break up the video halfway through with some tests that show that a solid holder is probably going to be a lot better than a hollow shanked holder. Almost proving it, probably definitely indicating that it's a better way to go. Thanks guys. Okay, well, let's see if we can summarize some of these points I've been making in the last couple of videos. So you're trying to decide on what spindle you want for your Tormach or other light CNC machine, and typically you'll have the option of R8 or BT30. R8's a very versatile system because you get collets and you can hold your cutter directly in the collet. You can have a dedicated R8 holder, and you've got the advantage of the TTS system with a 3/4 inch collet. So there's your options with R8. With BT30 you've really only got dedicated holders and probably a pull stud on the top, not this example. Okay, so if you're going to be doing a lot of manual work and you're not likely to run an auto tool changer, then R8 makes a lot of sense. But let's say you definitely know that long term you're going to be running an auto tool changer. What's the best system for you if you're going to be running an auto tool changer? Okay, let's go into the advantages of one versus the other. So a BT30 system with a pull stud on it is probably going to be more secure because the pull stud is a mechanical grip holding the 30 taper inside the spindle, and the TTS system is just a collet frictional grip pulling the flange up against the bottom of the spindle. So BT30 wins that one. It's going to be more secure, more positive. It's probably going to be more reliable. You know, in some of the comments in the YouTube videos and the forum threads and emails I've had, quite a few people have had trouble running their auto tool changer with TTS reliably. They're not confident about it, and every so often it crashes, and they're really are quite nervous about operating it. I'm sure that there's plenty of people that are running their TTS system in an auto tool changer reliably, and they've got it fine-tuned and they've got their machine working properly, and it's not a problem. But there's quite a few people that are having difficulty running TTS reliably. So I'd have to conclude from that the BT system is more likely to run reliably, all things being equal. It is just a more convenient shape. A taper and a pull stud, there's a lot less to go wrong than a parallel fit inside a collet pulling up on a flange. There's a lot more things to go wrong with that auto install system. And another advantage of a BT30 is it's probably going to be more accurate. A longer taper and a pull stud is going to be more accurate than the various diameters of the inside and outside of the collet, adding layers of inaccuracy to the assembly with the TTS system. So in summary, probably the BT30 system is best if you're going to be doing only auto tool changing work, but there's a price to be paid for that because you need to have spindle orientation if you're going to retain the drive dogs. If you remove the drive dogs, it's possible to consider having a machine with no spindle orientation, but let's assume Tormach will continue with the drive dogs. Then spindle orientation is another layer of complexity, things to go wrong, and greater expense. And the TTS system doesn't need that, and the actual holders are less expensive. So the TTS system is more affordable. The BT30 system is probably better for auto tool changing. I should probably put in a bit of a caveat here, because in some ways I'm not the most qualified person to be doing this summary of the pros and cons of R8 versus BT30. I don't have a power drawbar and I don't have a tool changer. And perhaps I should just briefly say my reasons for that was that I'd seen online that several different people were having trouble running their tool marks with the tool changer reliably all day long. And to me, the whole point of a tool changer is that it must run reliably. And so I thought, rather than investing in all of that ancillary equipment and bumping up the cost of the machine, I'd buy a base machine for about $8,000 and then later spent that money that I would have spent on a tool changer and power drawbar and compressor and all the bits and pieces on another base machine. And then so I built my own standard and enclosure and got two 1100s going for a very low cost. And the plan is, and it has been working really well, is that I can run the two machines at once and just move backwards and forwards between them, doing the tool changes, loading in the parts, cleaning away the swarf, measuring quality control and so on. Very much a hands-on production situation. And I think that suits lower cost machines that aren't highly reliable. And it seems to me the next step up is going to a vertical machining center where you get a higher degree of reliability. But that's just my take on it. And I know a lot of people will argue with that, and I know a lot of people have reliable toolmax running tool changes all day and not having any problems. I've just read quite a few people that are having difficulty with this, and it just makes me a little bit wary. So that's my background on this situation. So I'm probably not the most qualified, but I thought I should put that in as a bit of a caveat so you know where I'm coming from. I've also not got a power drawbar or a tool changer because I like the versatility of this option. A manual drawbar makes it easy to change different collets, different dedicated holders, and of course the TTS, which you can do easily with a power drawbar. So in this discussion I'm saying that the R8 system is more versatile. And that's certainly the case if you've got a manual drawbar. But what if you've got a power drawbar? I mean, what are the percentages? I know there's thousands of Tormac mills out there, but what percentage of them have a power drawbar? Is it 50%? What percentage of those with a power drawbar have a tool changer? Is it 10%? I don't know, I'm just guessing. So if you're one of the, whatever it is, 50% that has a manual drawbar, you easily get this versatility. But if you have a power drawbar, and again, I'm not qualified to really talk about this, but I imagine you can still install collets and dedicated holders with a power drawbar. I gather that you can quite quickly remove it and install a manual drawbar. Or maybe within the actual power drawbar itself, you can still install dedicated collets and dedicated holders. You've just got to fiddle around for a little while screwing them on and adjusting them. Now I don't know how long that takes, but it must to some extent take away from the versatility of the R8 option. So this is very complicated. It's simple to say R8's more versatile and BT30 is better for tool changes, but if you have a power drawbar, it becomes a little bit more complicated. Some of you will know how much it slows down the versatility. So that's another thing to consider. Okay, another subject to consider that, again, I'm probably not the most qualified, but I want to try and draw all these points together in a video to at least help you people to focus on it while it's uppermost in my mind anyway, is that let's say you're in favor of the BT30 with the pull stud because you're going to be doing mainly tool changing work, but you also want to somehow have the versatility with this system. I mean, why can't you get a BT30 collet with a pull stud on the top and still use TTS? The TTS holders you already have, or the lower cost ones you want to purchase in the future, and have the versatility and the better system for the tool changer. Well, that's a good question, and I've been looking into that, and I think there's a few problems. The power drawbar system to operate the pull stud is fundamentally different. from the power tool drawbar system to operate the R8 collet for the TTS. It's of, as far as I can see, and I'm not an expert on this matter, I don't own this equipment, and it's just from what I've read that the travel requires more travel to operate the pull stud, and it doesn't require as much force. So if you've got a system designed for the BT30 pull stud, it might not be ideal for operating a collet and the TTS system. So some work needs to be done on the development of a universal system there, and I don't know if that's being considered or not, but this could be problematic. So keep that in mind, that you may not be able to operate a collet for a TTS in the BT30 anyway, because it doesn't have has too much travel and not enough force. Okay, that's one thing to consider. Another thing to consider is that the BT30 system has got lugs, drive lugs on it, and they're going to get in the way of the TTS flange. So okay, you could remove the drive lugs, and then but then you've got gaps. Is it a good idea to be pulling the TTS up on the bottom of the spindle where there's gaps where the drive dogs were? It's not a full circle. That's not ideal either. And the diameter's a little bit out. You really want a slightly bigger diameter on the flange. And so there's about 4 different reasons that put a question mark over how well that's going to work. I'm sure there are solutions and ways around those 4 different problems that would obviously need to be coordinated by the machine manufacturer, and it's a complicated subject. So don't assume that you will be able to get a collet and use your TTS on your BT30. It's possible, but it's not a guaranteed thing at this stage. So keep that in mind, that your BT30 that suits a tool changer may in practice be limited to that type of tool holding. And even if those issues were to be sorted and you could install a BT30 TTS collet with a pull stud and operate it fine, then you still haven't got as versatile a system as an R8 system, because you can buy a big range of R8 collets, and as far as I'm aware, you cannot easily buy a big range of low-cost BT30 collets. I just don't think they're available. But certainly there's a big range of low-cost R8 collets available. So it's always going to have the edge anyway in that regard for versatility. And one of the reasons I've been considering this is that in the future it may be that a lot of these machines will be coming out with BT30 and pull studs on them, and my probe, the impact tolerant touch probe, so far has the TTS type 3/4 inch shank and flange. And so should I be considering supplying collets and so on? And so with what I've just said, I think a better option, rather than having collets because of all those 4 or more problems, is to either make an adapter sleeve that can be supplied and fitted over the TTS shank on the probe and permanently locked in place, and then the tip is dialed in concentric with that permanently installed adapter sleeve to BT30, and then you can get repeatable concentricity, and it becomes effectively a BT30 probe with that permanent adapter sleeve mounted on it. That's probably the best way to go. Another option would be to manufacture replacement shanks, so that you just completely remove the shank and install a BT30 shank on it as a replacement. That's another option too. So I'm considering those 2 options. At the moment, BT30s are not very common, certainly not on Tormax, and I'm not sure in which direction they will be going with all these various issues I've been discussing here. So we'll just have to see how it goes. Okay, well, my conjecture is that the R8 collet won't hold a hollow shank TTS as well as a solid shank TTS. And I've done a few tests so far in the other videos to indicate that, but I wanted something a little bit more conclusive. So I've put the R8 holders in this 5C collet block, and I've tightened up the nut to 70 pounds force like this, and I've tested in a press the solid shank holder and the hollow shank holder, and I'll just show you now that little test and the interesting results. Okay, so we have the hollow shank TTS tightened with a torque of 70 pounds on that nut. Let's just put it in the press now and find out what force it takes to press it out. I don't have a very sophisticated press, but this will give you, this is one way of measuring the force required. So we should be able to hear it break free. 3 pounds, 4 pounds, 4 pounds, it's breaking free. 3 pounds, about 3.5 pounds, 3 pounds. So it's 3 to 4 pounds for the hollow shank holder to break free. Okay, now we have the solid shank TTS set up in there, and we've tightened it in with the 70 pounds. Let's see what effort is taken to push that out. 2, 3, 4, 5, 6. So that's about double. 4, 5, 5, 6. So between about 5 and 6, and the other one was between 3 and 4, wasn't it? So this is taking a lot more force to push out, confirming the theory that the solid shank holder really is gripped better in the R8 collet. Sure, that's a 5C collet, but it's a comparison test, so it's pretty good evidence that the solid shank holder helps a lot. Okay, so let's take this opportunity to go through some of the comments and responses and try and wrap this all up. I'm not sure I should be using people's personal names, so let's just call this person DD. Has put forward a proposal for a cat R8 that's using the R8 tapered portion and having a little short holder with a pull stud on it. That way you could have a very efficient, streamlined auto tool changer system like a Cat 30 or a BT30, but it would be just using an existing R8 taper. There's some YouTube videos about that online. It wouldn't have drive dogs, but you could argue for these low powered machines you don't need drive dogs. So that is another option, Cat R8. Another guy's come up with some good points. Call him JE for privacy. He's got a R8 system in his mill, and he runs a 7.5 kilowatt motor to drive it and takes big cuts, 50 diameter cutter with 3mm deep cuts, high feed rates, and he finds the R8 system is plenty rigid enough. So probably an R8 is as good as a BT30 in terms of actual strength, or if not as good, very close. So this chap JE has proven to his satisfaction that R8 is great for taking big cuts on his machine. What else have we got here? Do you need to have drive dogs? Some people are saying that drive dogs are really unnecessary on low powered machines, and it adds the expense of spindle orientation. If you remove the drive dogs and just rely on the friction of gripping on the taper, that's probably more than adequate if you've only got 1 or 2 or 3 horsepower. For example, there's an Emco mill and holders that don't have drive dogs. It just comes out as new without drive dogs. And there are tool holder manufacturers, for example, Mari Tool, M-A-R-I, Mari Tool, that make cutter holders without drive dogs. So there's a good argument to be had for not bothering with drive dogs in these low cost machines. Somebody else asked, we should consider having a dual contact between the 30 International taper and the flat surface on the bottom of the machine to give more rigidity and a very accurate repeatable Z height. And I would say the trouble with that is just expense. In order to manufacture spindles to those levels of tolerance, very, very accurate diameters have to be retained on the taper, and that's very expensive. And it also means that every cutter holder has to be made to high tolerances, and we're in a market of low cost budget machines here, and so I don't think it would be lovely to have, but I just don't think it's realistic. Here's somebody else commented that a pull stud is more reliable than relying on the TTS system. Yeah, and that's something I've just gone over with that brief introduction. I agree, it does look like it's a more reliable system, and that there are people with TTS that are having trouble with running the machine unattended and reliable. In the last couple of videos we talked about what causes TTS cutter chatter and TTS pullout when you've got a large diameter cutter and it's standing out of the tool a long way from the spindle and you're taking a big cut. It's causing the whole TTS and cutter assembly to flex, chatter, and you run the risk of it pulling out of the TTS R8 collet and getting a meltdown. So what I wanted to do was to measure scientifically and not just conjecture whether having a solid shank really does make a difference. In theory it should, and we showed the test with the drawbar that it was collapsing the tubular shank and not collapsing the solid shank. In theory, you know, I'm sort of theorizing that it should pull out more easily. It should cause more flex of the cutter and more pull out, more ease of pull out, more chatter problems with a hollow shank than with a solid shank. But I was wondering, how can I really test that? I don't want to overload my machine, you know, as I mentioned in the earlier videos, and damage my spindle bearings. I need a way of measuring this without doing that damage, and I don't want to spend hours and hours making a complicated test rig. So I've dreamt up this method that is relatively quick to put together, and please feel free to reproduce it if you're interested. So what this is a way of measuring the stiffness increase at the cutter tip of a solid shank versus a hollow shank. So this is a solid shank TTS here, and what we have installed in the test rig at the moment is a hollow shank TTS. And I'll just put the camera on a tripod and show you the test, which should better explain what I'm doing rather than me just verbalizing it endlessly. Well, first of all, let's just go over what the test rig is. So I've got my TTS holder here, and it's being held in a 3/4 inch 5C collet block, and it's being tightened up here at the back. And I can get a repeatable tension on that nut. A bit dark down in there, isn't it? I can get a repeatable tension on that nut by using this scale. So I'm putting 50 kilos of force on the tightening between one test and another. I've got a dial indicator measuring the amount of flex under load, and I've got a clamp acting as a spring which produces the load. So when I move the cross slide, that screw bears on the end of the dowel, which is representing the cutter. And I have a dial indicator. Oh, this is all a bit crowded, isn't it? I have a dial indicator here which measures the amount of flex of the clamp, which is effectively a spring, and that is effectively a measurement of load. So I get a measurement of load from that dial indicator. I get a measurement of flex from that dial indicator, and I get a measurement of tension of the collet system with that scale. Now those three indicators ensure that I can get repeatable results. Now of course this is not internationally calibrated formal measurements, but they are useful measurements because they're repeatable, and I can put in a solid shank TTS and a hollow shank TTS and actually measure the flex end results. And yes, certainly has shown that a solid shank TTS flexes less. I'll just put the camera on a tripod now and do the at least some of the actual tests so you can see how it works. Okay, let's zoom in on these dial indicators so hopefully you can see them reasonably well anyway. Okay, so now we've got this dial indicator here set on 0. The other dial indicator there is set on 0, and the screw connected to the spring is not yet in contact. So as soon as it comes in contact, you'll see the dial indicators move. See there, it's starting to move. That's representing, that's showing that the screw's contacting the end of the dowel. So now I'm going to put a load on it. So that's the top indicator measuring the load of 15 on the dial. Camera's a bit in the way as usual. It's quite a lot, a high load. I wouldn't want to put that load on spindle bearings. That's why I've done it the test rig like this, because I'm getting quite high on my loads. So there's a measurement of 15 there. Is it? Let's have a look. Yeah, about 15 there. And I'm getting a flex of 25. Now, if I replace that holder with a solid holder and do the same test, I get a much less flex. I get a flex of about 15, and so you can see there's quite a big difference in an increase in stiffness where it matters. So this is the stiffness that matters really. When you've got a big cutter in there and you're taking a cut down the side of the cutter, what happens is the cutter is inclined, the whole assembly right from the spindle and the R8 collet, pulling the TTS and the whole TTS holder flexes, and it's that flex that allows chatter and pull out of the TTS system. And so what this is doing is measuring the flex and measuring the difference by making one small change. By having a solid shanked TTS versus a hollow, we're getting quite a lot less flex. I've done the test a couple of times, and on average the difference is 15 flex with a solid shank TTS and 25 flex with a hollow shank TTS. Now of course these are not internationally calibrated measurements of any kind at all, they're just comparison, and they may not be linear, they may be logarithmic scales, so one division may have 10 times the significance and so on and so forth, but it is comparison, and so it is very useful, and it demonstrates fairly scientifically the benefit of having solid shank. Of course, even with a carefully controlled test rig like this, there's a lot of variables. I mean, there's a lot of inaccuracies with the system and a lot of differences between this test rig and an actual machining situation. You know, I'm using a 5C rather than an R8 collet system. The flange contact is different. There's all sorts of errors in what I'm doing, but it's a comparison test, and I've done the test about 3 or is it 4 times now, and each time the solid shank shows to have less flex at the end. And so it is highly likely, although not 100% proven, but it's highly likely that a solid shank, if you're machining something and you're a borderline situation and you're getting chatter and you replace the cutter with a solid shank, you're probably going to shift that borderline into a point where you're not getting chatter, and that's what really matters, the relative difference. And so that might mean that you can use a 12mm cutter instead of a 10mm cutter, or a projected length of cutter of 40mm instead of 30mm, and you know, so that's a really worthwhile to know that there's a big advantage there. All right, well, that's probably enough, isn't it? Please note, these are only my thoughts. I don't have a tool changer myself. It's just how it seems to me from a distance. Thanks for watching, guys. Cheers.